Hello, Professor. This is Valerie Dillon-Mendoza, and this is my midterm presentation. I am recording it while presenting it to my spouse to help me focus on the teaching aspect and also feel less awkward, like I'm talking to myself. So with that out of the way, let's begin. One of the most effective ways to learn new material is to apply it to your own life. So that is the approach I am taking with this presentation. I am particularly interested in learning and how people learn. And so I am looking at the concepts from chapters 1 through 8 of Cognition by Daniel Reisberg as they relate to how people learn. Before we can go any farther, considering how these concepts relate to learning, we have to come up with some kind of working definition for learning. In the late 1940s, behaviorism was one of the primary schools of thought in cognitive psychology. At that time, many behaviorists believed that learning could be explained simply as a change in behavior. But behaviorist Edward Tolman disagreed. He argued that learning involves the acquisition of knowledge. This concept was one of the factors that spurred the cognitive revolution that gave birth to cognitive psychology as we know it today. So we will use this as our working definition. What does the acquisition of knowledge mean? What is it composed of? What is required to obtain knowledge in this way? We can break this into 3 parts. First, we must perceive the new knowledge that we wish to acquire. So the first part of our textbook that I want to look is the sections on visual perception. Secondly, we must pay attention to the new knowledge that we wish to acquire. So I will visit the sections of our textbook about attention. And lastly, for learning to be useful going forward, we need to remember it. And so we need to discuss memory. The first concept related to more than visual perception, but we'll start with it in the ideas of visual perception, is Gestalt philosophy. The basic premise of Gestalt philosophy is that the whole is greater than the sum of its parts, and we can illustrate that really simply. I've put some shapes and lines on the slide. They're just shapes and lines. However, if I were to arrange them, you might begin to perceive these as something other than 3 ovals and 2 lines. Perhaps you might see a glass. This perception will become clearer when I introduce more context. Context brings us to another point from perception, the idea of unconscious inference. Unconscious inference says that our perception of constancy is influenced by relationships within our retinal image. Essentially, relationships and context are key to how we perceive images. Now let's take a look at this second figure. We also have a series of line segments and a circle. What do you see in this one? Well, the idea of recency says that because our brains are quicker to identify recently perceived images, you might have at first seen this shape as a cup. But again, when we introduce concept, we can see that we were misled by that idea. It is in fact a clip art of a bill. The last idea from our textbook's treatment of perception that is useful when thinking about learning is the idea of frequency within our visual field. Let's use an example. As I unveil this series of images, note how long it takes you to identify each one. If my example is good, should have noticed that it took slightly longer to identify the orange. This is because our brains are quicker to identify images that we perceive frequently, in this case, the onions. But there's more going on than just perception here. That's because I also primed you. The idea of priming brings us to the next section of our textbook that I think is related to how we learn. The section on attention. I mentioned that I'd primed you. Priming is defined as a process through which one input or cue prepares a person for an upcoming input or cue. In the example with the onions and orange, I used repetition priming, which is priming produced by a prior encounter with the stimulus. So not only was it faster for you to identify the onions than it was the orange, I'd also primed you to pay attention to the onions. Also at play in the onions and orange example is expectation-based priming. You saw an onion, then another onion, then another onion, and maybe by that point you'd made a conjecture that you were going to be seeing a bunch of onions. Another example of expectation-based priming comes from the monkey business video that we watched in class. I had seen the video before, so I knew that there was going to be someone in a gorilla suit walking through while we were supposed to be counting passes of the ball. I was expecting the gorilla suit, so I was paying attention to it. How does expectation-based priming relate to the structure of our brain? Expectation-based priming is a function of the prefrontal cortex, which is a region of the brain that is especially active during careful planning and analysis. The prefrontal cortex is also known as the home of the executive functions. Executive functions are important for attention because they are the system that controls thoughts and behaviors. But what exactly does priming have to do with learning? We can think of priming as leaving little breadcrumbs that help lead us along a path to upcoming concepts. Now that we've addressed some ideas related to learning from perception and attention, let's turn to memory. And while we're at it, let's narrow our working definition of learning down to be a little bit more focused on memory. We can now consider learning as the creation or strengthening of memory connections. That's a little breadcrumb because I'll talk more about memory connections in a little bit. When thinking about the acquisition component of memory, it's helpful to get a sense of the working memory system. The working memory system can be defined as a system of neural processes that manipulate conscious thoughts in the present. It is the how of what you are thinking about right now. Now let's do a little experiment with working memory. I'm going to show you a series of letters. I'm going to show them to you for about a second. I want you to remember them and see if you can recall them to memory after I've covered them up again. Ready? Okay, quick. What were all those letters? If my hypothesis is correct, you probably don't remember many of those letters. Let's try the experiment again, using a slightly different way of arranging those letters. How about now? Do you remember those better? Our experimental concept is that working memory has a limited capacity. We just demonstrated that, because when you were just looking at a series of letters, it was difficult to remember all of them, but when we made them into words, it was a lot easier. So why was it so much easier to remember the second set? One way we can think about it is that in the second set, you looked at the letters in chunks, that is, as words. Instead of seeing WORKING, you just knew working. Chunks are a way to reduce the load on working memory. The term was introduced by cognitive psychologist George Miller as a way to describe the packages of concepts that are treated as a single concept by working memory. In this example, each word functioned as a chunk. While I didn't include this on the slides, another reason related to chunks that it was easier to remember the second set was because our visual perception is biased towards words. So not only is it easier to remember the series of letters chunked into words, but it's also faster to perceive them. Another reason that words were easier to remember than a series of number is because words have meaning. With a word, we can think about, what does this mean? What is working? Working is persistently doing a task that requires effort over time. We can also think about the relationship between these words. Working and memory are related, as are limited and capacity. Meaning and relationship create connections between ideas, connecting our chunks together. All of these memory connections create a network, and these networks are useful to help us create retrieval paths that enable us to find a concept by addressing a series of related concepts. So, for example, the first time I heard the word chunk was in a Coursera class. When I hear chunk, I could get to the meaning of it by going from word chunk, Coursera class, concepts learned in Coursera class, something else, definition. However, I also have now linked chunks to working memory via our textbook, so I might be able to take a bit more of a direct path. The more connections you have and the more organized those connections are, the more efficiently you can retrieve desired material from your memory, specifically long-term memory. Memory connections aren't just limited to concepts, though. Context is also embedded in our memory alongside concepts. There's a parallel here with the role of context in perception. The glass provided context that helped you perceive the series of shapes. Examples are also a form of context. When I talked about the gorilla video, I was providing a context for the concept of expectation-based priming. Places can also become contexts in our memory connection network. For example, maybe you're grading this presentation at home. The context of home will be embedded in your perception and your memory of this presentation. This idea is encapsulated with the term encoding specificity. Encoding specificity says that the context in which or with which a concept was learned is also remembered in connection with the concept itself, and this context becomes part of the meaning made. This tells us that memory, and by our previous definition of learning, therefore learning, is context-specific. There's another kind of context that I haven't mentioned yet, and that's the context related to self. The self-reference effect says that people have a tendency to better remember events in which they were involved. The self-reference effect is one of the reasons that active participation in class is so important. If you're not involved with the lecture, it's going to be harder to remember it. One of the kinds of context related to self is emotion. Perhaps you are feeling extremely aggravated by my extensive use of clip art. That aggravated emotion will be tied into your memories of this presentation as well as the actual content. And that may be a benefit for your learning. You see, emotion enhances consolidation. Consolidation is defined as unconscious biological processes that stabilize a memory after that memory is no longer being processed in working memory. But why would emotion enhance consolidation? Well, fMRI scans show that activity in the amygdala, which is the emotional processing center, is correlated with activity in the hippocampus, which is the memory processing center. So when the amygdala is fired up because you're feeling irritated about clip art, your hippocampus is also revved and processing memories more. Okay, well, that's great, but what about these breadcrumbs? Well, these primed breadcrumbs actually lead us back to the idea of the Gestalt philosophy, that the whole is greater than the sum of the parts. You see, what is remembered is one's understanding, not the event, the concept, material, or even the context, but the whole is what is remembered, not the parts. But what does that mean for learning? From the concepts I've highlighted from our Cognition textbook, chapters 1 through 8, we can get some concrete tools to aid in learning. First, we know that we can use frequency and repetition to speed up our perception. We can also prime expectation-based attention. We can use primes to help us pay attention by leaving a trail of breadcrumbs, previewing ideas a little bit like clues in a murder mystery. We can use these expectation-based primes to create a scaffold or an organization for concepts that will aid in our reaccessing those later. We can make more connections between concepts, new and old, by focusing on the meaning and the relationships between them. We can acknowledge and be intentional about the context of learning. After all, context means more retrieval paths. Reinstating context can help us access those retrieval paths. And lastly, as I did in this presentation, we can identify the personal relevancy. We can involve ourselves and/or our emotions in the material. Not only is this whole presentation an exercise in identifying personal relevancy for me, but I also used this earlier in the presentation when I asked you to participate in experiments. In fact, throughout this whole presentation, I have tried to use these 6 lessons for learning. So, how did I do? I recognize that I didn't stay within the specific chapter to concepts, next chapter to concepts. So I've laid out all of the concepts I covered and what chapters they correlate to. And just as an added bonus, I guess this presentation worked pretty well as a learning method for me because I was able to list all of the concepts I covered from memory.